Hi everyone, welcome to my YouTube channel, and we will talk about problem 694 from Leetcode. The title of this problem is finding the number of distinct islands, and this problem is very similar to the one that we have seen before. I think the title of that problem was number of islands, and here we have a number of distinct islands. So let's look at the problem statement, and this is the problem statement. For this problem, I have two approaches. My second approach is much better than my first approach, but my second approach is also based on my first approach. So if you want to look at my second approach, I will leave the timestamp in my comment section, so you can just go straight to my second approach. So let's talk about my first approach. So for this kind of problem, we will be running DFS. We have this for I in range of, say, rows, for j in range of columns. If grid at I comma j is equal to 1, then we run DFS, right? So we will be running like 1, 2, 3, 4, 5, 6 in this way, right? So when you do that, we notice that like this guy and this guy. Well, so for this problem, we have two islands, and the first entry that we will hit are those two guys. So this guy and this guy. They will be always at here, like the first guy and then second guy. This guy represent like coordinate for this first island, and this guy represent the coordinates for the second island. How do I get this? Well, when you run DFS on this guy, and this is my order of traversal for my DFS, because DFS we have to look for is 4 adjacent neighbors. So when you hit this 0, 1, the next guy will be 1, 1, and then the next guy will be 2, 1, and then the next guy will be 2, 0. That's how I got this coordinate. Actually, my DFS here, I should also have empty arrays. How we will store all these coordinates, and we will return it and set it equal to path. Okay, so that's what's going on here. So if you look at these two guys, how can we determine whether they are distinct or not? So that's the key idea for this problem. And my way of doing this is we translate all these coordinates so that we are looking at whether they are exactly the same or not. And how do you do that? The way I did it is I changed this, so this 0, 1 and 1, 4 into like this guy, 0, 0. And then, so we have to find out how much we have to move in like horizontally and then vertically. So that's given by delta x, delta y. Once we find delta x, delta y, we apply that to the remaining coordinates. Let's do this. So for 0, 1, when we want to translate that to 0, 0, our delta x will be 0 and our delta y will be -1. From 1, 4 to 0, 0, our delta x will be -1 and delta y will be -4. So we apply that to the rest of the coordinates. So in this case, we would have, so this guy, first guy will be 0, 0. Second guy will be 1 plus delta x, that will be 1. 1 plus delta y will be 0. And 2 plus delta x will be 2. 1 plus delta y will be 0. And this one will be 2 and -1. Here we have 0 and 0. Next one, we have 2 plus delta x, that is 1. 4 plus delta y, 0. That's 2, 0. And 2, -1. Now we notice that they are exactly the same. My second step will be, I will come up with, say, a set, and then I will add this, like this bunch of this guy into our set, and for the remaining candidates, if we have already seen that candidates like in our set, then we just discard it. If we have, say, pzdid equals set, so the next step will be, second step will be, I will be importing this default dict from collection module. We will be storing like all this guy, like 1 and 2, into our path dictionary. And the key will be the number of entries. So here in this case, I had four numbers. Here I had four entries. I have four entries here. So that's how you store this. Keys, we can have say key 6, 7, or 100, etc. It doesn't really matter. So once you build this path dictionary, the next step will be you have to find the duplicates. And that's this part, right? We have to find delta x, delta y. We apply this change, this translation to the remaining coordinates, and then we use set. Then we just, and then in the end we return the length of set. And that's it. That's for this problem. This is my code for the first approach. This is the second part. We initialize count variable equal to 0. This is the answer that we will return. And for each items in our dictionary, we run this function find duplicates, and this is our find duplicates function. I think in my previous slide I talked about coming up with a set and then find the duplicate, but here we have a list instead of set here. So we have a list instead of set because list is unhashable. So I made a mistake in my presentation, but yeah, so this is how I did this. Here x and y, this is your delta x, delta y. If we have seen array, like bunch of list of coordinates, then we decrement this count variable like k by 1. And yeah, that should be it. And let's run this. Yeah, so that's what I got. Let's talk about my second approach. Before we talk about my second approach, I just want to mention that here I said I create a set called visited, and that's how we find the duplicate, but I made a mistake here. If you look at my code, I didn't use set, I just used an array. That's because list is unhashable type in Python. So yeah, so that's why this wasn't true. But just look at my code, and I used an array to find the duplicates. And so let's go back to my second approach. So instead of returning coordinates, if you look at my DFS here, I return these coordinates, right? 0, 1, 1, 1, 2, 1, 2, 0. So instead of doing that, I return string NSWE. N stands for north, S stands for south, some things like this. This is my new slightly modified DFS, where I plus 1, j is really S, so south, north, east, and west. This is my new DFS. My question is this good enough? And it is not quite there yet. Why is that? Can you see the problem with my DFS? When we are running a linear scan on our grid, for I in range of number of rows, for j in range of number of columns, if grid at I, j is equal to 1, then we run DFS. So when you initially run DFS, you have to add something to our current move here. You can add any string that's not related to NSWE. So I just put O there. You can put say A, B, C, something like that. It doesn't really matter. But yeah, that's something that you have to keep in mind. So this is not good enough. Why is that? Let's look at this, our new second example. When you run DFS on this, according to my new DFS here, this is the output you get, right? You can try this on your own and see if you can get this. According to this, well, they are the same, right? OESE, but they are clearly not the same, right? How should we make some change so that our DFS will show that they are clearly not the same? And also, when you run DFS, after we exit DFS, we use this Python join function to, return a string, something like this, OESE, something like this. Okay, so this is just something that I want to mention. How should we do this? Well, simple. Here in our DFS, we have to backtrack, right? When we backtrack, we just add another letter. So why not B, right? Because B stands for backtrack, right? So I can create, say here, I can say what should I? So we should have something like this. So let me use same color to be consistent. So we have path dot append, and then we add letter B. So that's B for backtrack. Okay. If we add this, then this becomes what? Instead of this, we will get first one is O. We are looking at E. And then we will be looking at S, south. And then here, we are looking at this guy, E. Well, we have already seen this. From here, well, this is not true. Invalid coordinates. Nope. And we already have seen this guy. So we backtrack, right? We backtrack. Oops. So we backtrack. That's where B comes in. And then here we backtrack again. And we do backtrack again. And backtrack again, right? Because here, let's see. Right, from here, none of this satisfies. So we have B there. You backtrack. And then that's for this guy. And for this, that's this guy. And for this last B, that's for this guy. So we have O, E, S, E, B, 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 B. For this one, what do we have? We should get O, and then we would have E, and then we would have S. And then now we look at this. Well, this is invalid. Nope, nope. And then we already have seen this. That one should become B. So we backtrack, and then we are at here. Now we go to east, right? So that's east for this guy. And then we also, and then when we are at here, well, this is invalid, 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 and we already have seen this. So that's gonna be B again, backtrack. So we backtrack. From here, we backtrack again. This B is for this backtrack, and then we are at here. So we are at this coordinate, and we backtrack again. So B. Now we see that these two are not the same, and we use this join function. And in this case, we can create a set. So in this case, we can create a set, visited, and that's how we visited equals set. And this is how we will, return the answer. Just when we finish linear scanning, we return the length of visited, and that will give us the right answer. Now, and let's look at the code. Alrighty, so this is my code for the second approach. And yeah, so when you're in a DFS, if this condition is true, make sure you set grid at I, j equal to 0. You can create a copy of grid, say, I don't know, grid underscore copy, and you can work on grid underscore copy instead of modifying the given input. You can do that, but for the sake of simplicity, I just chose to modify on the given input. Yeah. And let's run this. Alright, so that's it for this video, and if my video helps you guys, please give me thumbs up and subscribe to my channel. If there is some improvements that I need to make, write a comment down there, and I'm happy to engage with you guys over the internet, right? So that's for this video, and I will see you guys in the next video. Thank you and bye bye. Have a great day.